This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club. It's another fantastic presentation ahead, and we are celebrating session number 50 today. I'd like to just give a few reminders before we get started that this session is being recorded. There will be Q&A after the presentation, and please feel free to post your questions in the chat room and we will field them through there. We're always looking for future presenters, and the training team can help create training materials that may be unavailable. So feel free to contact Brian Mott at the Office of the Chief Learning Officer for information or questions regarding that. Since we are celebrating 50 sessions of the Satellite Book Club, going back all the way to May of last year, missing only 3 weeks for the holidays, I thought we'd just give a little bit of a summary and start out by thanking, first and foremost, all of our audience participation, our presenters and our facilitators over the years, as well as our Tower S team, Kashad Bowman, Lee Byerly, the Office of the Chief Learning Officer, the GOZAR and JPSS programs for their support. So the Satellite Book Club is here to foster partnerships between NSDIS and the National Weather Service. It's the insight that you provide will ultimately shape future efforts of the satellite community. We've covered a broad range of topics with presentations from users, developers, and other leaders. And once again, a big thank you to everyone who participated and attended the Satellite Book Club. And as you'll see on the next slide there, we have had participants, presenters, and facilitators from all over the country. So it's been really great to see this success, and I hope you'll continue to join us in the upcoming year as we continue the Satellite Book Club. All right, let's switch over to today's presentation now. The title is CIRA's GeoColor Imagery, coming soon. The presenter is Paul Schlatter, the Science and Operations Officer from the Denver, Colorado Weather Forecast Office, and the facilitator is Dr. Dan Lindsey, the GOZAR program scientist. Paul is the Science and Operations Officer at NWS Boulder. As Sue, one of his primary duties that he is responsible for is ensuring new science and technology is incorporated into operational products and services. Prior to being the Sue, he spent 5 years at NWS Headquarters in Silver Spring with several roles. The most recent was acting chief of staff. He began his weather service career at the Warning Decision Training Division in Norman, Oklahoma, and is former president of the National Weather Association. Our moderator, Dan Lindsey, welcome back. Paul, take it away.
All right, thanks. Happy to be and honored to be speaker number 50. I guess it was just luck of the draw. But yeah, I'm excited to talk about GeoColor imagery because frankly, I love it so much. It's one of the coolest things to look at on a daily basis. It's one of the best things we can post to social media to get our message across about just what's going on generally, or if there's something really cool going on, getting the message out with GeoColor has been really good. Major kudos to Dan Lindsey for, he built all these satellite loops. Let's be honest, I'm not skilled enough to make these types of loops, but Dan did. And so thank you, Dan, for all these great loops that we're going to look at. In general, it's going to be a lot of eye candy, but I think that's what we're all here for anyway. So let's go to the next slide. Before talking about GeoColor, now I should have mentioned the title of the slide. If you're a weather service forecaster in an office, or heck, even if you're just an enthusiast that may not work in an office, you have access to GeoColor. We all have access to GeoColor. The change that's coming is that they're going to build an RGB GeoColor that is made on the fly in AWIPS. Joe and Dan are going to have all the details on when that's coming, how that all works at the end of the presentation. So my presentation is mainly just focused on operational usage of GeoColor across the US and mostly in our office too, the neat things we get to do in Colorado. So GeoColor was developed at CIRA by Steve Miller, and it does approximate the true color imagery from the ABI during daytime, and then at night it switches over to an IR-based product to help with the low clouds, especially low clouds, the water-based clouds, and the high cloud detection. And as I'll show a couple examples, it includes a static night lights background. At CIRA, before they ship it out to the masses, including our office, they use a Rayleigh correction, and so it makes it, the imagery just looks better. I can't really explain exactly how Rayleigh correction works, but I know everything's sharper, it just looks better in general. One of the, as we all know, way back in the day when GoZar was just in the planning stages, they didn't include a green band. So that can be tricky to build a GeoColor image without that green color for the things that are actually green. So the workaround there was that the component was built using lookup tables from the Himawari's AHI. And as you can see, the green shows up pretty well. I'm amazed that they were able to make it look so cool and so green without the green band. Next slide. So easily the most important usage operationally, I'm comfortable saying across the weather services for situational awareness. Speaking for just the Boulder office, I can guarantee you the first thing they look at when someone comes on shift is the GeoColor, especially if it's daytime. Nighttime, they look at it as well, but daytime, the first thing is GeoColor to get situational awareness. What's actually going on? Where do we have, are there low clouds? Are there fog? Just get a whole assessment of the situation, what to expect that day. And I think, we're humans. We've seen the images from space of the Earth and all the colors that go with that. I think we're just naturally, all of us are just naturally drawn to these types of imagery where you can see geographic features. Lakes show up really well, plains, valleys, different vegetative types, they all show up very well. So as you're trying to figure out where you're looking and get your spatial reference, it's way easier to figure this out than if you're just looking at a band 2 visible, the red imagery. It's much easier to discern those types of things. Next slide. Another application, but not just for our office, but gosh, from the 2020 fire season between California, Oregon, and Colorado, all epic fire seasons, and the amount of smoke was just ridiculous. But smoke shows up really well in GeoColor, a nice hazy gray, as you can see. You can really pick it out better when the sun angle is much lower angle. So dusk and dawn, you can pick it up really well. This wasn't from 2020, this was from 2019, but you can just pick out where all that smoke is across anywhere you're looking. Next slide. Dust shows up really well. This is over the Atlantic with a Saharan dust event blowing towards the west off of the African continent. Shows up really well as brown. We'll show some American dust because we don't want to leave our own dust sources out pretty soon, but really neat imagery. I'm not a hurricane expert, but I know that this type of feature is really important for the hurricane experts in the Weather Service, tracking where that Saharan dust goes. The nice thing is, I'll show an overland example from the high plains of Colorado and Central Plains. It shows up really well over water and over land. Next slide. All right, this was a fun one. This was what we call a BORA event from April 2019. A BORA event in Colorado. It occurs along the front range of Colorado, well, anywhere front range of the Rockies, really. And it's ridiculously strong northwest flow at all levels, usually in the wake of a powerful exiting trough. So there's massive substance forcing all the wind down the east slopes. And you just get a blast of northwest wind that starts at the divide and goes all the way out into the panhandles of Texas, Oklahoma, and eastern Kansas. And the result was 70 to 80 mile per hour sustained winds in April, so mostly before the green up. There's it just takes a few plowed fields or with no vegetation, and you get what happened here, a major dust storm across eastern Colorado, western Kansas, and then eventually, as that cold front progresses, you lose it at night, of course, but it progressed all the way into Kansas and Oklahoma. The neat thing is that very first feature there, this is crazy to me, that off the Great Sand Dunes, the San Luis Valley here, there was a dust and sand initially in the southwest flow before the cold front, the Bora cold front northwest flow took over and just wiped it all out. But that just blew me away that from the Great Sand Dunes, it could pick up sand and dust, cross over the Sangre de Cristos, this mountain range here, and then there you go. You've got multiple sources of dust and sand to look at, and just the features are amazing. Next slide. And Brian at the Sioux and Midland mentions you can see smoke and wildfires over eastern Arizona. That's true. You could see that in there too. Yes, there are better products for detecting low clouds and fog. The nighttime microphysics, the nighttime cloud products that they have out there, those are all fine for looking at stuff too. But for a situational awareness type of thing with the city lights as a background, we prefer to look at the GeoColor for low clouds and fog, just because it just looks cooler. We can spatially, we know where those clouds are relative to the city, especially relative to Denver International Airport, which it's near that cursor. I don't think, yeah, there it was right there. It's that little blip right there all by itself out there. We could see that it was over, but it just gives us better spatial reference when we're using this product versus a more standard products that we have. Next slide. Just a comparison between the low cloud and fog detection day and night between the microphysics RGB. Again, we really do like this product. We use this just as much as the GeoColor, but with the spatial referencing, it's just easier to pick out. If we were to social media this, we would prefer to show this because one, the general public wouldn't pretty much have a better spatial resolution. Two, whenever you post a microphysics RGB, you got to explain what every single one of these colors are. And this one, you say blue is fog, and kind of leave it at that. Explanation much easier. The other neat thing about GeoColor is that at the transition zone between around sunrise, it's much more seamless picking out where the fog is versus, in this one where the transition is just a little bit not as clear cut once it goes to the visible. I'll let it go through one more time. That's what I wanted to point out. You kind of lose some of the features. Actually, you lose all the features by the time the sun comes up, but it's seamless with GeoColor. Next slide. All right, active fire and smoke. So this is major fire number one. This was the largest wildfire in Colorado history. It occurred in Larimer County. That's just west of Fort Collins. This was when it made a huge run on October 14th. Actually had to evacuate portions of western Fort Collins, the metropolitan part of Fort Collins, the western edge of there. And looking at, if you looked at photos from Fort Collins, which is literally right under my cursor there, if you can see the cursor, maybe not, probably can't see my cursor now that I think about it because Kashad's showing it, but yes, right there. So go downstream of there, it looked like the end of days. The sky was completely orangish black, street lights were coming on. And this showed it all. If we were to social media this, people would get the picture that this was a serious situation. But it's nice because you can see the fire itself, the hot spots, and you can see the downstream smoke in all of this. Next slide. The next slide should be East Troublesome Fire. This is when it made its major run. This became the second largest wildfire in Colorado history. And in one day, it jumped or spread 80,000 acres in this one event here, fueled by 5% relative humidity and wind gusts to 75 miles an hour. Not a pretty day, but the fascinating thing is you'll notice on the east slope, we had a cold front move in. Upslope clouds formed. You can see all the various features of the canyons getting up to near, again, Kashad, if you can outline yeah, right in there. So that made it up to about 9,000 feet. The continental divide's still above that. So it was 40 degrees and chilly on the east side of the divide, while on the west side, clearly, without the advantage of a moist cold front, that fire just went nuts. But a really nice visual, both for us for situational awareness and any social media. Next slide. Here is some of the ways that we have done social media. On the left, for snowpack. GeoColor looks great for snowpack because you can pick out geographic features really well. And it just makes sense. People can find out where they are. The New York office likes to show it as well. I mean, everyone does. Everyone likes to show it on social media just because it looks so cool and the public understands it. Hit the next one, and I'll show you, this is the full state blow up of that image. So everything on here is snow except for some clouds in just west of Denver. You can actually see the shadows of the clouds, which GeoColor does a nice job of doing. Those are wave clouds right over the divide, but the rest of the state is pretty much covered in snow. Really neat image. We got a ton of feedback on this particular one. Next slide. This was a more recent downslope wind event. This was a traditional Chinook mountain wave event. And again, we're not using GeoColor to forecast this to detect downslope winds. We have surface observations for that. The HER model does a good job of telling us, especially cross sections and model soundings, where that inversion is going to set up to force the winds through the channel. And then you set up a mountain wave with a critical layer and all that good stuff. I just love looking at this. You can see wave clouds that are really narrow at first, forming, this is dead center, just east of the dead center of Colorado. And then throughout the day, you see that wave cloud expand east. And when that wave cloud expanded east, that's when the winds actually picked up. It was gusting to 74 miles per hour right by our office here. This was a prolonged event, and you could probably tell that by just looking at how long the wave cloud lasted the entire day. The strong winds, although they fluctuate a little bit, they were gusting over 50, almost the entire loop of this. They were gusting more than 50. And then towards the end of the loop at 21Z, they finally weakened below 50 miles an hour. But it's just great stuff to look at for visuals in general. Next slide. All right, I'll turn it over to Dan and Joe about how we're getting and what's new about what we're getting into AWIPS soon.
All right, hi everybody, this is Joe Zajic, and Dan, do you want to start off, or you want me to just kind of roll right into this?
Go right ahead, Joe, you can take it.
All right, so you guys have had this Steve's and Dan's work for several years now. The data is being provided by CIRA. It's on their slider application, and also it's going over the regional LDM, which has bandwidth limitations. And that's been, as Paul's clearly demonstrated, proven out the worth of this data set. If you ask Andy Just or Chad Gravel or many folks, bandwidth WFOs and the regional LDM is a dear resource that is right there at capacity. So Dan was very interested in trying to figure out how we could get this data off of the communications network, and because it's computed completely from data that's already on the AWIPS, basically some static lookup tables and information and five bands of ABI imagery. It was a good candidate to compute directly on the AWIPS system. So Matt Foster from the OPG did a bunch of heavy lifting and translated Dan's Fortran code into Python and got it basically working. And then from there, myself and the Tower S team have collaborated with him and moved it forward to try and incorporate it into our Tower RPM and get it deployed everywhere. So we're going to get this done in conjunction with our Tower S RPM version 21. Hope you all tune in next week at the book club meeting for our rollout presentation. That'll be Lee Byerly and John Evans will be talking about everything version 21, and it'll be coming out actually next Thursday. The data sets that will be available are for both GOES 16 and 17. Well, whatever you have on your AWIPS. So if you're all the way on the East Coast and you're not copying GOES 17, then you won't get that. But GOES 16 or 17, it goes east-west. It'll be the high-resolution 500-meter based version of this product, and we'll have all of the high-res sectors, the full disk, the CONUS. Well, it'll be the 6-kilometer full disk, the high-resolution CONUS, high-resolution mesos, also the Puerto Rico and Alaska sectors will be computed. This high res, if you're getting the data from the regional LDM today, you're getting a 1 kilometer version. The high res is an advancement that Steve and Dan made by doing some pan sharpening on from the 500 meter 0.64 the red band operating on bands 1 and 3 to get that texture that the red band has applied to the other 2 bands. So in terms of timing, we're working with Andy Just at the Central Region Headquarters to get this checked out on his AWIPS, and he's working it on the current version 20.2 and also the upcoming 20.3 versions of AWIPS, and then it'll be deployed out as a companion to the RPM version 21. Right now it's looking like it'll go out as a local app. Ultimately it'll be included in future versions of the RPM. So that's the game plan, and I'll turn it over to Dan for any comments, and then we'll move on from there.
Thanks for that, Joe. Appreciate it. And I appreciate Matt Foster and your hard work and everybody else that's contributed to getting this released into an RPM. Exciting. Next slide, please. And I'll just show really quickly as the last slide. This is an example that we grabbed actually last week from AWIPS. So it's basically what it will look like in your AWIPS. And this is the 500 meter version. Those of you who are pulling Goes East from LDM, or like Joe said, are just getting the 1 kilometer version. And this is the 500 meter version, which really sharpens things up and allows you to see some more details, especially some of those smaller scale cumulus clouds that you can see over there over South Florida. Okay, so Paul, thank you very much for the excellent presentation. I really appreciate that. So before we go into the Q&A session, I would like to ask everyone to stick around for that Q&A session in just a few minutes here. Also, please share any feedback that you have on this session or Satellite Book Club in general in a short survey that will be linked, if it's not already, in the chat. I'd also like to provide yet another shout out, this was mentioned earlier, for next week's Satellite Book Club, Thursday, May 27th at noon Eastern. John Evans and Lee Byerly from Tower S are going to discuss the new content and updates in the Tower S RPM version 21. So definitely tune in again next week for those details. Okay, so now let's switch over to the Q&A session. I'm going to scroll up and take a look at the questions that have been coming in. Let's see. So Brian mentioned smoke that was available in the dust loop, and I think Paul did acknowledge that already. And absolutely, it's you can see both types of aerosols, both the smoke and the dust, in that example. David asks about the daytime background. Is it static or live? I'll take this one just because I can speak to that. So the answer is it's live. With the one caveat that since we don't have the green band, that's what Paul mentioned at the beginning, we have to simulate the green component, and that's done using lookup tables, which were built using Himawari data. And so that simulation of the green component will sometimes result in colors that look a little off. You can see an example of that actually in this right here, off the coast of the Bahamas. You see some colors that look just a little bit strange. I think that is a direct result of the simulating the green component. But for the most part, especially over land, it works really well, and what the true color we think really should look like if you compare it to something like Veers. Okay, so let me go down and see. So Chris, yes, that's right. Thanks for helping out with that answer. Tim Barker says bandwidth is important, but so is load speed and performance on AWIPS. RGBs take a lot longer to load. Any comments on the RGB version of GeoColor will compare to the current ones? That's a question maybe for Joe or.
Yeah, sure. I'd be happy to talk a little bit about that. The RGBs that you're currently familiar with, what they call the on-the-fly RGBs, are done as derived parameters inside of the Cave application. And you're right, there are several of them that the more complex they get, and especially the ones that involve band 2, are slow to be computed and it's a problem. You do have the benefit on some of the interpretive RGBs of being able to, well, I guess some people think it's a great idea to be able to tweak them, some people not so much. In this case, this implementation is actually computed upfront in Python outside of the AWIPS application. So as the bands arrive, they're plucked off of LDM, the RGB is computed, and it's ingested just like any other product into your AWIPS. So it should ingest and display basically as fast as any of your single band imagery. We are actually looking at using this framework. Once we have this successfully deployed and everybody's comfortable with it, we'll potentially offload some of the more complex current on-the-fly RGBs to this. Again, the benefit will be the load speed. The downside will be you can't tweak them.
Thanks, Joe. And just to clarify something, you said the data will be plucked off of LDM. I think you actually meant that the data will be plucked off of SBN, right? It's the data flow coming in.
Well, yeah, I'm sorry. The source is SBN, but it's the LDM, the instance of LDM on the AWIPS system. I should have differentiated from the not to do with the regional LDM communication network.
I see.
The LDM, the LDM application running on the AWIPS that ingests the SBN data.
Thanks, Joe. Appreciate that clarification. Okay, let's go to the next question. This is from Tim Schmidt. He says, since it's already in AWIPS, can you address the uses for the non-Rayleigh corrected Sims natural color relative to GeoColor, and how do the speed compare? And he also asks, at night, do you use the fog and low stratus product suite? So let's take the first question. We actually anticipated this question, and so loaded up an example. Kashad, if you could scroll down to the end of the presentation real quick to do a comparison. So this is GeoColor and this is the Sims natural color, and you can kind of just go back and forth to toggle there, Kashad, for to see the difference. And I'll let Paul speak to actually answer the question.
Yeah, that's the first time I'm seeing the comparison, because I don't think we get the natural color Sims natural color imagery in our office. If we do, we haven't really looked at it. But gosh, to me, it's night and day better. The GeoColor is for the contrast of the, I guess those are contrails out in the southeast U.S. Frank, I know you're on. I'm sure you'll tell me if I'm wrong about that. But it looks like contrails. You can pick those out better, and just the land surface is much easier as well. So yeah, I like it a lot better.
This is Frank. I don't know if you can hear me. Those are contrails, as a matter of fact. We've looked in the southeast certainly at both of them. The natural color is nice because it comes in a little bit quicker, and some of that sounds like that will be resolved with the GeoColor. But we've used both in operations, and the natural color has shown some use, especially if you have it loaded for like a convective situation, because previously we could only get the 1 kilometer, was only at CONUS level, whereas the natural color we could actually run it on the mesosectors, which we couldn't do before. So it'll be nice to see that the GeoColor will be there as well. But the natural color has proved useful up to this point to fill a bit of a gap that the GeoColor did not have in there.
Rick made a good point on the delay. I should have mentioned that while we're watching. I mean, the main reason we use it for situational awareness and not for like severe storm detection is because it is delayed getting into our office versus the stuff we get off the SBN.
Yeah, latency is critical, so that's a good point. And then, Paul, do you want to take the second part of Tim's question? He's asking if you use the fog and low stratus product suite.
We do, yeah. We'll for fog detection, especially if there's another layer of clouds out there, we'll use anything in our arsenal there to try and detect the fog. And so, absolutely, yeah. Daytime, nighttime, all the different fog products. We look at all those. We're mostly drawn to the microphysical, the night microphysics one, especially at night, because it's instant. It doesn't have that 3-4 whatever minute delay we get in GeoColor. So we do primarily rely on that.
All right, let's keep moving here. It is past the bottom of the hour. Those who have to take off, obviously feel free to do so, but we're gonna go ahead and keep going here while we've got some good discussion and questions. And just one more quick reminder to share feedback using the link that Lee has posted to the chat there. So Paul Iniguez is asking, it looks like he's echoing Tim's question and wondering about the impact on the workstation. I believe that's been addressed. And I guess we'll just kind of have to wait and see once it gets deployed how it works out for everyone. But based on Joe's response, it sounds like it should be an improvement over some of the other RGBs. Okay, Tim Barker, excellent to know that it will be pre-computed. That'll make it much less memory intensive and load faster. Yeah, that's what we're hoping. And I think that should be an advantage. Let's see, Darren asked, glad to hear how this is being computed up front. The new higher res version looks really cool, excited. Yep, thanks, Darren. Joe is saying that the natural color is a traditional on-the-fly RGB. And then Darren says, the biggest issue we've had with the current GeoColor is lag time download over the LDM versus real time, and this will resolve that. Yep, that's exactly the goal of this. We actually consider this a weather service operationalization, because basically the RGBs that you're already able to compute in AWIPS are basically operational. It's done on the fly with the data coming in via SBN. So we consider this in making GeoColor operational, at least specific to weather service. Okay, so that's all I'm seeing in the chat. I'm going to pause. Okay, so Joe is saying that the link to the survey doesn't have session 50 as a choice. That might be something that Kashad, you may have to resolve. So sure he'll get that done. Last call for questions.
Dan, just a question for you. This is Jordan. One of the things that we've seen with the GeoColor is the nighttime lights base map, and I'm wondering for the JPSS users out there, is there a need or desire, either from the field perspective or from the developer perspective, to create a nighttime map that updates hourly that updates daily, most likely because of the temporal resolution of the satellites that carry VIIRS. But is that something that we need to have that would be useful for applications?
I'll pause and see if anybody wants to speak to that. While we're waiting, I will say that I know a challenge with that, Jordan, is clouds, because the city lights mask is done by basically taking a year of data and doing very careful cloud clearing and screening out everything that's not a city light. So if you tried to use just the observed day-night band imagery, you're going to end up with clouds and other things that are kind of messing it up. So it would be a challenge, but I would like to hear if anybody thought that would be useful.
Well, this is Frank. I'm speaking for myself, of course, but I think for the purposes of looking at GeoColor imagery every 5 minutes or so, assuming it's CONUS, I don't think it makes that big of a difference. Now, if you were doing something a little bit deeper and you were trying to get into the guts of it and start analyzing some of the pixels and doing some calculations for a study or something like that, that might be something that would be worth it after the fact. But operationally, I don't think that would be a particularly big deal. As Paul mentioned, when we get to night, a lot of times we're using things like the nighttime microphysics RGB versus any one particular band. So my hunch would be is that it would probably be more work than it's worth for what we use this for in an operational basis. But again, that's just me.
Thanks, Frank. Let's see, Galena asks if we could use updated city lights as a map layer in addition to the static map. Maybe. I think it would definitely some work involved to set that up. The latency, as Frank alludes to, of the VIIRS passes is a bit of an issue too. Bill's asks, are there plans to do this for Veer's GeoColor for Alaska AWIPS users? That's a good question. I don't know if we've talked about that, but anybody can chime in and answer that.
Well, Veers has a green band, so it's a little bit different question, I think, right?
Well, I think maybe he's referring to putting Veer's GeoColor in AWIPS in a similar fashion as this.
Yeah, Veer's GeoColor in AWIPS using the same computation format.
I don't know, Joe, has anybody approached you guys about that? Not hearing any replies. Joe may be gone. So I guess the answer to that is no. Oh, go ahead.
Yeah, I'll just say, I mean, we're actively working with Alaska to establish requirements. They haven't specifically pointed out this need. They have a lot of polar orbiting satellite data available to them. It's something certainly through the proving ground, that the topic that might be discussed. So good question, Bill, and we'll follow up with Alaska to see what their needs are.
Speaking of Alaska, Joe mentioned earlier that this will be available on the GOES 17 mesos at the half kilometer resolution. And I've never actually looked at an example of this in Alaska at half kilometer. So once that's available, I'm really interested to look at it and see. Of course, there's a limitation when you go way far north, say northern Alaska, on the resolution due to the pixel sizes, but it still should be pretty useful, I think. Okay, so the last question this is one that on the topic of city lights, this is back to Paul again. So early on with GeoColor, we had some mixed reviews on the city lights. Some people didn't like it. They thought, what's the point of having these city lights on there, especially due to the fact that they're static and they never change. I was just curious how you guys feel, Paul, about, do you like them, or would you prefer to have the product without the city lights background?
Just speaking for myself, I love them. I definitely think they enhance the product, and everyone, at least in my office, also likes them. I've asked them about it, so I don't know if it's different in other offices, but I know for the Boulder office, we like having the lights on there.
Okay, cool. Yeah, I feel like that's what the majority of people have said. I think now that people are used to them too, maybe it's not so strange, because if you show it to the public, they think, oh, I didn't know GOES-R could detect city lights, and you have to tell them, well, it's not actually from GOES-R. Okay, so one more comment. We'll be excited to see that in Alaska. Thanks for the meso ad. Yeah, absolutely. I'm excited too, Samuel. Okay, so that wraps it up. Lee, Jordan, Kashad, any other last comments?
Dan, I'll take it from here. Appreciate it. And thank you, Paul, for your presentation. And also thank you, Joe, for addressing how our sites are going to get that into AWIPS. Lots to be excited about. And I'll just wrap up with a little bit of a final comment about the city lights. Is occasionally in GeoColor, the fade in of the city lights doesn't quite match up perfectly. And I was talking to a senior NOAA leader once about that we had the GeoColor up, and they asked why the city lights were on before it was dark on the East Coast. So there is a little bit of user interpretation that has to go on with that actually that map layer is static and not something the satellite is sensing. So anyways, perhaps a little room to tweak how the city lights are faded in at nighttime. And with that, I'd like to thank everybody for joining us for the Satellite Book Club Seminar Series, session number 50. I hope you'll be with us not only for session number 51, but for session number 100. And session number 51 next week, Thursday, May 27th, again at our traditional noon Eastern time. We will have John Evans and Lee Byerly from the Tower S team, and they are going to be discussing the new content and updates in the Tower S RPM version 21. So with that, I hope everybody's spring and summer are off to a great start. Stay well and see you next week.